Hello, this is part 3 of my MA300 lecture on Chapter 1. This is on Section 3 of our textbook, and it talks about other sampling designs. In Chapter 1, Section 1, we discussed the different kinds of statistical studies that we can do, whether they were descriptive or inferential, or the studies could be experimental or observational. Then we talked about how we might start selecting data for our statistical study. In section 1.2, we talked about what was called simple random sampling. But is simple random sampling always the best way to go? Let's consider a discussion of the idea of boating safety. Let's say that the Coast Guard wants to put out some new boating safety rules and wants to get some public opinion. And so they put out a nationwide survey. They randomly select people from throughout the United States and ask them their opinion on these boating safety rules, usually ocean-going boating safety rules. Well, the question is this a good design? Well, most likely not. And the problem being that, let's say that a farmer in Wyoming gets chosen for this study. Does the farmer in Wyoming really have much interest in ocean-going boating regulations and rules? Most likely not. Whereas somebody who lives in Virginia or Rhode Island or on the West Coast near LA might have a differing opinion and might consider these rules important regulations. So a different kind of sampling design might be considered to be important to them. So what are some of these kinds of designs? Well, one type is called systematic random sampling. And in systematic random sampling, we divide the population size by the sample size that we want, round the result down to the nearest whole number m. Then we're going to use a random number table or similar device as we did in section 1-2 and obtain a number k somewhere between 1 and m, and then select these samples. This seems like a complicated procedure, but essentially it almost works like this. What this sampling method tells us is that, let's say that I'm at a shopping center and I want to start picking shoppers to give a random survey. What do? Well, I might choose every 10th shopper, knowing that there's going to be 500 shoppers going to be coming in, so I need a sample of size 10, right? And so I'm going to start with some random number between 1 and 10, and that number person will be who comes into the door of that shopping center will be the first person that I ask. And then I'm going to ask every 10th person after that for their opinion. This is called a systematic random sampling. But we'll show an example of how this works here in a moment. Another kind of procedure that we use is called cluster sampling. Cluster sampling might be the one that we'd want to use for our Coast Guard rules. The way we deal with it is that we divide the population into groups, clusters. How do we choose those clusters? Well, typically we choose them by geography. We might be interested in choosing clusters of people for our Coast Guard survey who live in the New England area, or groups of people who live on the Mid-Atlantic coast, or the Gulf Coast, or the Pacific Coast, or in Alaska or Hawaii, and ask them about their opinions, right? So we can obtain random samplings from within those clusters and decide what we want as our result. So we divide up the population into groups, obtain a simple random sample from within each of those clusters, and then use all the members of that cluster as we talked about in step 2. A third procedure is called stratified random sampling, and in stratified random sampling, we look for some sort of proportional allocation from within a population. So what we do is we divide the population into subpopulations. A good way of thinking about this is that if we want to divide up a population, make sure that we had an equal number of men and women. Well, our strata, our subpopulations, are male population and female population. We may also be interested in classes in a college, so we may divide up our population of students into freshmen, sophomores, juniors, and seniors, or graduate students and to ask them about their particular opinions based on that subpopulation. So from each stratum, we obtain a simple random sample of size proportional to the size of the stratum, that is, how big it is, right? If we have a certain number of people within that group, right, we want to make sure that our size for our sample is proportional. That sample size is then we look for a simple random sample from within that strata and then divide the population and use that to obtain our sample so that every population is hopefully fairly represented. This is usually an example of something that we might deal with if we have a race or a question on religion, or perhaps a question based on age groups, which is very big in advertising, for example. Well, let's go through an example of this. Let's sort of contrast the idea of simple random sampling with another kind. So let's deal with this. Let's talk about our game of Keno. In the game of Keno, those of you who don't know or have never tried it, Keno is a game in which 20 balls are selected at random from 80, with numbers 1 through 80. And typically, players will pick a little sheet where they will pick off a set of 10 to 20 numbers. And if their numbers turn up in the winning selection, well, then they might win some money. Depending on the game, it could be if they have 5 right or if they have 10 right. The games themselves start with a random selection. So let's simulate a game of Keno by obtaining 20 random numbers 1 through 80, starting with a 2-digit number in column 5, column numbers 31 through 32, as shown in our last video, and read down the column and up the next, and so on. And then we'll compare that, by the way, in our discussion board to a random number generator. You're going to use one from Excel on a program that I've posted on Canvas to do this. Okay, so if you've taken a moment, open up your book to Appendix 1, Table 1 in Appendix A, and simulate the game of Keno by obtaining those 20 random numbers. We'll compare our answers. Okay, here we go. This is what I found. My selections from the table, when I chose them, according to the simple random sample, were here. The numbers 38, 53, 30, 9, 62, 45, 75, 3, 65, and 69, 2, 17, 45, 44, 28, 16, 62, 15, 78, and 34. Now, if we wanted to use a simple random sample from a systematic point of view, if I wanted to use systematic sampling, here's how that might actually work. If I followed a systematic procedure, we might say, all right, we have 80 total numbers, and we want a sample size of 20. That means we're going to use m equals 4. Now, I flipped a coin twice. I flipped 2 coins and came up with a little table of values that would help me figure out what my sample size should be. And of course, I randomly chose 2 out of 4 as that number. So that means that I'm going to start with number 2 on my table, go to random number 6, 14, 10, 14, 18, right? Every 4 numbers here, and so on down the list. And that's how I might choose systematically from my table. All right, so this is an example how we just pick some random numbers based on either a random sample or a systematic random sample. Now, if I wanted to, let's try another problem right here. Students in dormitories at a university in the state of New York live in clusters of 4 double rooms called suites, and there are 48 suites with 8 students per suite. We might be interested in designing a cluster sample procedure using a sample for obtaining a sample of 24 dormitory residents. So think about that for a moment. How would you describe a cluster sampling procedure to do that? Now, students are typically choose friends with from their classmates as suite mates. So most people will try to get in a suite with 4 of their friends, 3 of their friends and themselves. With that in mind, do you think a cluster sample is a good procedure for obtaining a sample of dormitory residents? And explain your answer. Now in C, the University Housing Office has a separate list of dormitory residents by class level. The number of dormitory residents in each class is shown as follows. There's 128 freshmen, 112 sophomores, 96 juniors, and 48 seniors. Use this table to design a procedure for obtaining a stratified sample. So we're going to compare a cluster sample, and this time a stratified sample, with proportional allocation of 24 dormitory residents. All right, so take a few moments here, write out your answer, pause the video, and then we'll come back and take a look at your answers to compare. Okay, ready to go? Here's my answers. First of all, we have 48, right? 48 suites there are 12 clusters. So we might select a sample of 2 from each of the 12 clusters, right? So if we're looking for a sample of, obtaining a sample of 24 dormitory residents, let's say we select a sample of 2 from each of the 12 clusters within our population, right, that we've chosen. So we might want to make sure that we have people on different floors, or if there are a couple of different buildings, we want to make sure that we spread them out evenly throughout the 2 buildings and then randomly choose a sample of 2 from each of those. So students typically choose friends. So what does this tell us about how good a procedure we have? Well, it may not be as good a sample as we want. It may, but it may not be, because we might accidentally choose a pair of friends as a representative sample. And if that's the case, of course, friends have this tendency to hold some of the same opinions, or at least sway each other's opinions in matters that might be important to dormitory life. And so getting those friends, we want to make sure that if we get a sample, how do we avoid that particular problem? Well, we're given a list in Part C here of housing officials as a separate list of residents by class level. So maybe it might be a better idea to stratify those students and find out what a good size sample should be. So how should we do it? Well, probably the easiest way to do it would be to take our table of residents, which we're given right over here on the left, and we see we have a total of 384 dorms residents. Of those, 128 are freshmen, 112 are sophomore, 96 are juniors, and 48 are seniors. So what do? Let's take a percentage. And the way we do it is we take 128 and divide by the total of 384. We find 33.33%, that is 1/3 of all of the residents, are freshmen. 112 divided by 384 would give us 0.292. So 29.2% of the residents will be sophomores. 25% are juniors, and 12.5% are seniors. So if we want a representative sample, that means that we should do the following. Out of 24 students, we take 33%, that is 8 out of 24, and make them freshmen. We would choose likewise 7 of our students in our sample to be sophomores, 6 of them to be juniors, and 3 of them to be seniors. This way we get a balanced sample that reflects the residency within this dorm in a way proportional to the entire group. Okay guys, that's it. That's how we would do this kind of sampling. We'll discuss these things and more on our Friday seminar as well. Have a great week, everybody. And we'll see you next time for our lecture for Chapter 2.